Dr. Donglai Dai. He's a chief engineer at X-ScaleSolutions, where he leads the company's R&D team. And the current work is on focusing on developing and enhancing communication libraries for various high-performance computing and deep learning middleware. Let's welcome Donglai.
Thank you for the introduction. Okay, so I'm going to give some overview of two of our main products today. We got more, so we'll talk on Wednesday. And so I'll also show some of the detailed steps, one of them, how to use it. So the two ones that I'm going to talk about today, one is for X-ScaleAI, which is targeted for AI applications. And the other one is for SecureMPI. This is for secure communication for HPC applications. Okay, so here is an overview. First, we'll briefly to some of them may know our company, so we'll give a brief overview of the company. Then I'll talk the two separate products. So as our company, X-ScaleAI, has been in operation since 2018. So it's more than 6 years. And we basically provide training product as well as commercial support for platform-specific optimizations as well as tuning and application-specific optimizations and tuning. Those are two different things, okay? And obtaining guidelines to use our products for best practice. And we also, since we are commercial products, we guarantee your service level based on your contract. And we also have a web portal interface for issues if you need help, as well as keeping the progress how they're addressed. And we also constantly update our product. If you have a contract with us, those updates is free. And we also are a winner of a multiple US DOE, Department of Energy, Small Business Innovation Research Award winners. And we're marketing our product basically in HPC as well as AI application, especially for communication-related stuff. And currently we have 5 major products. And it's basically, one of them is AnvaPitch library with the DPU offloading enabled. I'll show most of the latest result. And by the way, that's what Rich just talked previously before lunch. That's the DPU we're using. And we also have a product specifically for HPC. And we have a product for optimized version for PETSI nonlinear library for numeric simulations. And the next two basically is what I'm going to focus in this talk. And more information about our company as well as the product is available on the website of company website. Okay. And so I will give another talk on Wednesday at 2 p.m. Talk more about other aspects of other products. And so next we're going to talk about the X-ScaleAI product. So this one, we basically focus on high performance, we provide high performance solutions for AI problems on modern HPC systems as well as cloud platforms. And it's focused, the capability for this, we're going to focus is training for the AI models, as well as doing inference, as well as fine-tuning of the models. And the major feature we emphasize is mostly it's end-to-end optimized software stack with container, a very continuous deployment, okay? mostly today I'm going to only focus on the cloud-based solutions. So we have baked in all scaling and system optimization developed under high DL, which is OSU side of a project, but this is a commercial extension for the existing ones. And we also have additional specializations as well as optimizations for that. And we made it specifically available. Right now, you can access this on the AWS cloud and through the AMI container or virtual machine, depends on how you view them. And we also have one currently working, but it's not included yet. It's an obtainer for on-premise systems. Okay. And we support this model. This package support models that is defined by PyTorch or Hugging Face. Okay. And if you notice that right now we don't enable the TensorFlow stuff. And this actually models we support is including the large language model as well as vision model, and specific ones we listed here, which has been tested and is part of the product support. And others will continue to work to add more functionality as well as capabilities to it. And this model, this package also enabling scalable checkpoint. Okay, model checkpoint as well as a restart for continued running, multiple runs, but making continued progress based on that. And the emphasis here is it's out of the box. So mostly we'll see how it is helping the user to set it up, the install, as well as start using it in a user-friendly manner. And CPU we currently support include x86 as well as ARM, and GPU supported in NVIDIA, AMD, and Intel. Now, the thing with AWS, mostly it's GPU is based on NVIDIA GPUs. The interconnect, this model support, including the AWS fabric, okay, elastic fabric adapter, basically is Amazon's fabric. And InfiniBand, Ethernet, Rocky, and including OmniPath, that's what early on Cornell's network product. And the feature basically where this is a product with service, and we support both private and public models. Private, basically you commercialize internally, use it. Okay. And we can do the support for specific ones. And it contains sample recipes, how you potentially optimize if it's your private ones. You want to improve that yourself, but if you have a contract with us, we'll do that with you, okay, and keep the information private to yourself. And we have onboard scheming available as examples for new user and organizations to try it out, to see whether it's appropriate for them to use our package. And that's a few things we already mentioned. So as what this actually as a product that's added, why you potentially is valuable for your company or organization to take a look or try it out. This package is leveraged on the 30 years plus our expertise as well as our capabilities built into the team that enable scale out and scale up for AI applications. Okay, we use those knowledge as well as skills to apply it to this domain. And it's a reduction. Focus is the reduction of distributed training, fine tuning, as well as inference, parallel inference on a given hardware platform, including GPU, CPU, and interconnects. we do optimization in a holistic way, not just focusing on one thing. And the thing is, we emphasize performance portability across different platforms. So depends on what your environment is, and this could potentially give you a lot of leverage. You can start with some public cloud, and later on, you want to in-house, keep it most of the data or whatever training result in-house, you can move on to on-premise system as well. Those, whatever your training result as well as tuning result can be leveraged rather than start from scratch each time if you switch from different system to another platform or something like that. Okay, so the end result is, end benefit is reduced time to solution, time to market solution, okay? Time to market or time to solution, depends on who your customer is. And it's high throughput on given platform from multiple AI applications, and reducing power in usage, okay? And also carbon, basically environment friendly. And also we reduce total cost of ownership or total cost of operation for your application. And as this, at the beginning, when we, the package requirement, we try to isolate the details of the model from the end user. And the end user basically doing some parameter configurations or that type of thing without have to muddle with the model itself. So they provide some high-level configuration or parameter setting and using a configuration file. And this basically is in JSON's directory format. Okay. And we will take this, of course, we have examples for the end user. If the end user does not know how to do this, we'll help them to create this for their particular model. And then we take this as an input and generate a configuration file, okay, for the model. And once you've done that, then you can run your application. And this one is showing before we're doing the tuning or optimize using our package, okay, with whatever parameters you provided, and one is after. As you can see, this particular one is using distributed PyTorch, a model, okay, and which is basically ResNet 50, which is mostly used as benchmark for visual models. And here is a particular one. We're using Horvath because Horvath is the MPI framework that put onto PyTorch so that it can be doing distributed distributed training as well as all the modeling of that type of thing. And this particular system, the test was particularly done on Frontera, which is a TAC system. Okay. By the way, this is not a cloud, and this is on-premise. On-premise, okay, it's using for Quadrant RTX. This is not the latest GPU technology, but it's a decent one. And it's a one node, you have 4 GPUs, okay. And we actually here, we're just showing 2 nodes with total of 8 GPUs. And those nodes, between the nodes, the connection is 100 HDR, the NVIDIA HDR InfiniBand. It's a 100 gigabits per second bandwidth. Okay, as you can see, the impact of optimization is very prominent. Okay. It's several X speed up. And this one is another one is also use a distributed PyTorch as another example. And this is a bird from Google, the model, okay, large language model. And we're using AWS cloud. For the particular instance, this one used is G4DN.16x large. If you are familiar with AWS, there are so very different type of instances which has different components configured into that instances, like what kind of a CPU you use, how many GPUs are included in that particular configuration, as well as how it's connected between different nodes. So those are, for particular one, this one is 16x large. And the GPU with this node is, we actually have 4 GPUs. It's called Tesla 4, T4. It's a slightly older GPU technology, but it's what is installed in that particular instance, and it made it more affordable. Okay. But the good thing is our model will be optimized for this, and those models are portable. It's optimized on that, but whatever your result will be, it's portable. Okay. So again, it's used Amazon's Fabric. So as you can see here, it's a 50 gigabits per second. And here you can see the speed up is less. Okay. One reason for that is the computation is taking a lot longer because it's older generation. And this is another example. This is, again, distributed PyTorch. And this one is a vision model. It's ResNet 50. Use ImageNet data set. Okay. And the GPU now is 4 V100. This is one of the latest okay, mature. Of course, not the latest, the latest, but it's still considered very high-end GPU devices. And again, it's 4 GPUs per node. And between the GPUs on that node is connected through NVLink instead of InfiniBand. And then this CPUs is also 20 core, 2.5 gigahertz. This is Intel Xeon. And it has specific memory, DD4 memory, and as well as SSD storage attached to the local node. And the interconnect here is 200 gigabits per second network. So the network is also faster. As you can see here, optimization, you see much less. Okay. One of the things is a similar model. The computation for ResNet 50 nowadays is not considered that heavy anymore, not like a large language model or this kind of thing. Okay. And so this will be the last one on this. I think this will be the last one on this model. And this is calling parallel inference. And the previous examples are all for training. And so this one is, as you can see, this one we're doing that on Llama model. This is, I think it's from, what's that? Hugging Face as well as from, what is that? Facebook. Okay. And by the way, each of these are using different size of the problem. Okay, this is, the first one is J4B, 4 billion. Okay, the other one is 13 billion, then 32 billion. The last one is the largest, it's 56 billion. That's the parameters. hyperscaler. And this is compared to the default. The red one is for the faster transformer. That's the model we're using based on that. And this is after our improvement on using our package. And you can see the speed up, again, is very prominent. It becomes more and more so once you use more, you see more requests. You have sufficient amount of computation going. Okay. So these are the fundamental reason is because for all these models, I mean different models here, the average inference latency for a single request is much, much larger than default time intervals. And that allows a lot of our optimization for computation, communication over time, and optimization techniques will apply, make it more effective. Okay, this is the scalable checkpointing that we also support as part of the package. And this particular one, as you can see, that the default one for PyTorch related stuff, if you're looking at the right figure on the right, you can see that mostly it's growing at a projected, even though it's tilted a little bit, but it's going up on the linear degree, okay, linear trend. And for our package, we make this scalable so that, as you can see, mostly, initially it's going up a little bit faster, okay, than the default one. Then it's flat, growing at much lower rate. So make it more scalable. So this is a special features of this package building. Okay, so the next few slides will showing some of the usage, how to use this package. And basically, we list the three major steps, and within the major step, there's some sub-steps. Okay. The first is because we made this available in the AWS marketplace. So as a user, you first either have an account or create an account, AWS account on their AWS marketplace. Then from that account, you subscribe to our product once you find it in the marketplace. I will show a video, even though the video does not have audio, but to go through these steps. Now, once you subscribed to X-ScaleAI package or service, then there's two ways to launch instance of X-ScaleAI computation. Okay. The first option is to launch regular instances through EC2. That's the platform we're using. Okay. Interface by naming the instance. Okay. And select AWS instance type with matching AMI, which the X-ScaleAI support. And then currently, all the G4DN instance types, I will show you how many different types. Wow, it's a big list. I'm not showing you all of that. And we support by this package. And of course, more models will be supported later. And once you have that instance created, then you can select SS key to log in to configure everything else you need with that instance. And then select the number of instances, which basically means multiple nodes. Okay. Well, sometimes you can have multiple nodes within an instance. Depends on how that instance is set up. But mostly in G4D is one instance per node. And then you can have, once that instance is launched, like now you have a machine that you can use once that instance is launched in AWS terminology. Then wait it to be initialized with all the setup software stack as well as your file system and storage, all that type of thing. And then you can use SSH key to log into your machine, that AWS machine. By the way, all this actually is covered by much more simplified by E4S distribution. Okay, we are potentially can simplify these steps even further by adopting the E4S approach. And this video will show the steps. Okay, and basically this is to look for X-ScaleSolutions, how to find our product. Okay, then once you find it, then you click it, then you can subscribe it. Now there's different models for using this package. One is to subscribe it. You can use the we call it free trial for a period of time. You can do that. Or you really like it, then you can subscribe it as you go, pay as you go. Okay, you can see this long list of the types, whatever you like. Then this is first approach to launch it once you get that. Okay. You can name the instance name, and by default, we just call it X-Scale. And that one select one copy of that instance. So your system basically have one node. Okay. So that's the first step. Now, second step as a user, you use a parallel cluster. We will do the configuration and create it. So we just create a one instance, right? How many instances do you need for your real machine? And so the second step is a different approach. You want to create the system that you can reuse. You don't have to recreate it every time you want to use it. So you can create what is called a P cluster. And with a P cluster, you basically need to provide a configuration. And in this configuration, you basically define what kind of a head node you need, and what kind of a cluster manager you would like to use, and also compute nodes, how many compute nodes, as well as potentially different types, okay, the instance types, all that. And then you can use a command line, P cluster command line interface to launch X-ScaleAI runs using this configuration file. This approach, this is second approach, which is very similar to traditional HPC system usage. Okay, here is a second video to show this step. Okay, basically you create the configuration file, using YAML script. And you basically identify the type of instance nodes you want to use, as well as the cluster managers and the head nodes type you would like to use. Okay. And this is using this P cluster, which is the command in AWS system. So this is the result after you create it. Okay, you can double check whether this meeting whatever your expectation is. And this says it's creation in progress. It takes a while to let this to complete. So once it's done, you can list. This is the final result of this configuration. Okay. Okay, next one. So this is the last step for usage. Okay. It's now you have the machine created to you. You launch your job by using Slurm or whatever the scheduler or parallel job launcher you would like to use. Okay. And of course, that's part of the configuration you created. So here you log into your head node. Okay. And then in the head node, you do the allocation. You have the whole machine. You don't have to allocate the whole machine. Okay. You can allocate some part of it. And of course, you can allocate the whole machine if you want to. And you use allocate, and then you do SSH to part of your allocation. Then you launch your normal parallel job. And for here, this package, we actually have a specific command which doing a lot of fit in to figure out, to simplify your launch. And this one is called X-ScaleAI run. Basically, this is where you trigger the usage of our package. And so as you can see, an example is you basically use this command run, then you give your application as well as your specific application parameters. And this particular example is just run the ResNet and use a data set as the training set as well as the validation set. Okay. And you give the batch size as well as how many epochs you would like to run. For this simple example, it's basically use one epoch. Okay. Okay, so this is the last video to show how you run our package on your machine, AWS machine. Okay. So this is basically showing your resource on your cluster. Then you go to this X-ScaleAI package, is our package directory. Then we have some examples. Of course, if you have your real stuff, you can store it here. Okay. And this is that particular example how to run. And at this point, it's still already started running. This is output. So this is the beginning. You can see the first epoch. It started training. This is a progress part, percentage. Okay. And those are the result for the validation part. Later on, you can see. And for this particular example, the instance you selected is 8x large. Okay. And it has the GPU in it. Now the actually making progress. And this is the accuracy estimate and loss, model loss percentage. And this is a typical, that model particular one, okay, for ImageNet. Okay, so training for first epoch is done. Now the next one should start validation. Please. Is it done? Okay. I don't think we capture the validation part. But anyway, so those are the typical run you see. Okay. So that's for the first package, our first product. And now let's move on to the second one. This is a secure MPI package, X-ScaleSecureMPI. This is to ensure communication, to ensure secure communication, sorry, for HPC applications with minimum overhead, performance overhead. So the overall goal is to ensure secure communication for security-sensitive applications, MPI applications, running on modern HPC and cloud platforms with minimum performance overhead. The major feature is here. It's basically a scalable solution, okay? And it's built on top of the OSU AnvaPitch library. So we basically added security protection to this MPI library. And it's flexible support for multiple cryptographic libraries, depends on what is available, and different libraries actually perform on different systems with different performance characteristics. And also different encryption schemes. It depends on what kind of a level of protection. And it's configurable per request. It's part of a configuration for the library as well. Okay. And we are using TLS as well as SSL, security key management protocol, to make sure the whole computation session is secure with appropriate key management. We support secure point-to-point communication, both blocking as well as non-blocking, and also doing that for quite a few collective operations, including broadcast all-to-all and all-gather. Where also, for the first release, these are the basic functionality we will provide. For the future release, we are going to add more collective for secure operation communication. We try to keep the installation as well as execution simple. For a particular execution command, it's basically you switch the library you use without changing your application. Because as long as you're running an application with MPI, then we switch the MPI from the normal MPI library to secure MPI library. So, then you get the feature. Go
just
ahead.
A quick question. Does this work in the new enclave kind of concepts where once the data goes out of the enclave, everything has to be encrypted?
Can you restate?
So there is a newer concept called enclave for secure computing, where you have like a protected environment called enclave in which the application executes, and even the kernel does not have access to that location.
Oh, you mean enclave? Yes.
Yeah.
I think this itself does not increase that, because enclave mostly people are talking about is within a node, especially for memory protection, separations, all that type of thing. And this is mostly focusing on communication within the application itself, as well as between different nodes that you used. If you have a single node that has multiple applications running, which they don't collaborate with each other, that still depends on your system's protection, including OS as well as the hardware protection. Motion, do you have anything to add? Good.
Yeah, sorry, I was wondering. So, do you establish these keys at like wire up, at MPI init? Like, in other words, is this done through like PMI?
Oh, PMI.
Yeah.
Yeah, and that one Because we are carrying, mostly we're protecting data communication between the different nodes, the data. We don't directly use encrypt or protect your management, how your access or connected up. That's not part of this protection.
Okay. Thanks.
Okay. But that's a good point. What happens is if the system get hijacked, okay, now is, if that's the case, now whatever you are protecting is under that condition. But we still try to say, if you can launch, even it's get hijacked, if you can launch the application properly, we guarantee the communication between different nodes, as well as the nodes within, the communication within the application cannot be seen by others. But as you can point out, if the node is compromised, even the system protection is not guaranteed, right? So a single node will be compromised. But between the nodes, you still won't be able to see. You generate the garbage, the other one will detect it. But you cannot accomplish what is pretended to computation to go on. Does that answer your question?
Yeah. And so this is secure per job, per
Yes.
MPI? Okay.
Yes. Of course, that jobs is whatever parallel distributed jobs you are running. Okay. Any other questions before I move on?
Quick question down here.
Oh, sure.
Sorry, yeah. Does this work? Will this work with potentially any encryption scheme? So the reason why I ask is recently at SC20, I think at SC23, one of the best paper awards was this notion of fully homomorphically encrypted either reduce or all reduce. So it is a design like that? Is a design such as that presented in that paper available in X-ScaleSecureMPI, or is that something that?
That's a good point. That's a good point.
Reason being, one last elaboration, just because of how with FHE you can also perform arithmetic operations like MPI sum, product, whatever, without having to do intermittent decryption and re-encryption.
That's actually a good point. One thing I would like to point out is one of the things we say is we support multiple cryptographic library as well as encryption schemes. So those, as long as you point out that's as a requirement, we potentially can put the plugins for those without changing the major design framework, okay? The other one, even today, people are talking about post-quantum computing, okay? Now, most of the existing crypto schemes, okay, will be broken, okay? For us, we'll adopt the new crypto or whatever, which is a post-quantum computing, okay, without changing the overall scheme.
Got you, okay.
Okay, but we have not reached that point. We leave that flexibility and leave that plugin in place.
Got you, okay. Thank you. Thanks, Donglai.
Yeah. Any other questions? Okay. Hopefully